All right. Yes. Now we're recording, and I should share the screen. Let's see. Yeah. Right. So I had a few. So from the first week, there were a couple assignments, and I had a couple grades that people were not happy with, and that's totally cool. Like I actually enjoy the part where like either I graded you wrong, or there's some misunderstanding on my part, or maybe you need clarification on a specific point. Those are all very good things to me. So don't try and think of it as like, oh, I'm wasting the instructor's time. No, that's why I'm getting paid by the university, right, to help teach you. And so please take my time to learn and get that feedback. And then the other comment that I sort of observed while working with a student is that I forgot to mention in first class that there's three types of cells, right? There's markdown cells, there's raw cells, and there's code cells. Code cells are where your Python is going to get run. The markdown cells, they're JavaScript based. You can put in HTML code there. But that third type of cell doesn't get formatted and it doesn't get executed. So the value of that for this class is that you can put code in there that didn't work out. Right? So you tried something, it failed, you know it's a problem, and you don't know how to fix it, and you just want to leave me a comment and say, like, Ben, this is how I was thinking about the problem, I didn't get to work, but here's what I tried. And so basically leave some evidence about what your struggle was. Because if you just submit me a notebook that like runs without errors, but doesn't explain what you tried, then I can only judge you on what I see. So that's a little use there.
Can we get feedback from you on what we gave you?
Yes. So that's a good question. So the question was, will you get feedback from me? Most of the time, if you get a 100 on your assignment, the answer is no. But on instances where you get like points off, where that's like a minor thing or like some major points off, I'll typically leave some feedback about what I think the issue was and what that distribution of points was like. So maybe it's like 5 points for this, 20 points for that. I'll try and point to what specifically I was thinking at the time, so that when we talk, then I can reconstruct that's what I was thinking. Does that answer the question?
Not entirely
satisfactory, but yeah. So I think the technical question, like where in Blackboard do you see that as a student? Is that what you're asking?
That would be useful.
Okay.
But also, for those of us who haven't gotten some homework, would it be possible to get feedback for what? Because I don't know what you did right and what you did wrong, what parts of it you might have appreciated or not. You know what I mean?
Not quite, but so I think if you want to say like I got 100 points, I'm not clear like where I could improve. Is that the feedback you're seeking? Maybe? Yeah. So that I would say I'm probably not going to leave feedback in Blackboard on, but I'm happy to do that in person. Yeah.
And then the other question.
Yeah, where in Blackboard? I haven't navigated through Blackboard as a student to see where you see that. Okay. Yeah. So navigating through Blackboard as a student is something I haven't done. So, but I'll turn it over to your fellow friends.
Thank
you. Right. Then on methodology, so not everyone did the same homework, and I'm going to show you some code that was submitted in Jupyter as the homework, and these are what I call reference solutions. So these aren't like the right solution, they're just a solution that I found some aspect to be useful for commentary in class. And I don't disclose who wrote the specific submission, so if you're embarrassed that I'm showing your code, that's cool, I just won't call you out. But I will ask, like, does the author want to make a comment about what they were thinking? That's your opportunity to either stay silent, which is totally cool, or you can say, I wrote that and here's what I meant. And I haven't encountered the situation, but I'm sort of amused of like, two people will say I wrote that. I'll be like, oh, that's interesting. So don't give away yourself like that. But all right, so let's take a look at the couple of reference solutions for the syllabus grid. So if you didn't notice, this had like two purposes. One is for you to help understand how I'm grading you in this course. The other is to get some hands-on experience with Python if you're comfortable doing that. If you're not comfortable with Python, this will be the class for you to get sort of your feet wet and get some hands-on practice. Okay, so a couple comments about this solution. I really like the fact they used a markdown cell to have some commentary. Specifically, they restated the assignment. Now, why that would be useful is because then I know that they know what they're supposed to be doing for the assignment. Because like often I'll see like someone implements like half of the homework assignment in a notebook, and then they're like, well, that's all I read in Jupyter, or sorry, in Blackboard. And I'm like, well, that wasn't the whole assignment. So like having that restatement assignment is very useful for you and for me to know that you know. Okay. So nothing like crazy exciting here. This is all sort of like what I was expecting for code. The other thing that I really like about this one is that they had a comment in their code cell trying to explain like what's going on, right? Because it's one thing to say like, here's a variable, here's some math, and move on. Right? But like the statement in English is like, here's why this cell is relevant. All right. And then they gave some citations about like what sites they were drawing from. And they go through, like, if you don't understand all this Python code, that's cool. Don't feel bad. And it's just like someone else is doing that, but I'm trying to draw out the points that I sort of think is useful. Okay. So then at the end, they just print out their answer, and you know, that's sort of like what I was looking for a solution as an example. This is another solution, also correct. You can see here they also did the same concept that I requested, which is like they're citing sources they look at, sort of their thought process, the steps they went through, right? You can see that they weren't quite as delicate with the formatting, right? It's all readable, it's not executed, but this cell is code, and so therefore you don't get that formatting that looks like a nice document. So it's actually comments in Python, but it's marked as you know, English text to not be executed. Okay, so then this person probably has some experience with programming because they wrote some functions, and these functions do things and they return things. And again, that's something we'll cover in class today. So if you're new to that, yeah. So I think all of these are sort of doing the same thing. They all have the same features. Now this person went above and beyond in my opinion. Like they use pandas to do like a simulation of the entire assignment, gradebook. I mean, like that's pretty advanced. So if you're in that camp, cool. You'll probably be a little bored this class. I apologize, but that's just the way it is. So these things, like I'm gonna have. So the comment about this I would like to make is, I will try and find ways of challenging you if this is where you're at, right? If you're comfortable with Python and pandas and you're just like, I can do all this, but I'll still try and challenge you. We'll have to work together on what that looks like, right? There's plenty of work to be done in data science, and just because you can code doesn't make you a good data scientist. I had a couple professional programmers in my class last semester, and they still learn stuff, so I feel a little validated on that point. It's not just making things up. Okay. Now this is like a super common tendency. So if you're just writing code, it gets harder and harder to write documentation about your thought process. So this person is doing a reasonably good job of like, this is some complicated code with nested for loops. That's a structure that everyone here will master in this class. But that's like a pretty good structure, and they're also documenting about what it is that they're trying to accomplish with that code cell. Another thing to sort of show off is they're using cells to do little independent blocks of code. They're all executed in order from top to bottom, but they're sort of giving the reader space to be like, this is a chunk that you should load in your head. This is the next chunk you should load in your head. And so they're breaking, it's not just one giant cell of Python that you'd have to read through and try to internalize. You can break it out into cells, intersperse commentary about it, and that's pretty helpful for the reader. Right, so here's a counterexample to that. So there's a lot of code, and it is commented, so I'll give them that. So I can scroll up. Yeah, so they restate the assignment because this is as a comment, then you're losing that ability to like wrap the text and make it look readable, which is like a terrible thing. I mean, it's a good thing to include that. It's just not as readable. And you'll notice this person was putting all of their code, which is reasonably complicated, into one giant cell. So the consequence of that is you only have to press enter once to execute. So it's pretty, easy to use from that perspective. But if you're trying to read this code and understand what it does, it's a little harder. All right. So a usual breakpoint I would recommend for this person is if you have a loop, and then there's a break and it goes back and does something else and it does another loop, that point is usually a good point to insert a separate cell. If you have nested loops, you can't put, code breaks inside your nested loops, and so you sort of like are restricted by the nesting of your loops. But here, if you have sort of separate tasks and separate loops, those are pretty easy to find a breakpoint between. Okay. Yep, so here's just another sort of like pretty straightforward use of some functions and some markdown cells, and then they step through it as cells linearly, and then they end up with the answer, and that's it. So any questions on what I've shown you or comments from the people who wrote code? All right. So as I warned you, today's lesson on Python 3. So if you haven't heard of that before, now you can no longer claim that. We're doing Python. All right. We'll stop doing that. We'll stop on a little break on Python already. We're going to have an activity. That was a really short class, by the way. All right, so the activity is you read one of the two essays that was assigned last class, and you wrote an essay and submitted it to me, hopefully. And then the goal here is find someone else in this class who has not read the essay that you read. They read the other one, right? And then you will tell them what you learned in your essay. And you'll talk to the person and learn what they read in their essay. It'll be like a conversation where two people talk. And go. So if you haven't sat next to someone who read the other paper, it means you physically have to get up. That's crazy. We're going to take about 1 more minute, and then we'll come back to see. Okay, let's wrap up and come back to our seats. Okay, so over the course of the semester, I'm going to be repeatedly doing this to you, forcing conversation on a given data science related topic with someone that you hopefully do not know that well. And there's an ulterior motive, right? So you are, I would claim, in the highest concentration of data scientists that you'll probably ever be in your life. You're in a room with 24 other students who are going through the exact same process, the exact same location, the exact same time. And for the rest of your career, that's highly unlikely to happen. Unless you're at a conference for like a day or two, where you may be exposed to a few people. Right? But here, you're going to be exposed to the same people for semester after semester after semester. And you can either say, like, that's terrible because they're all dumb. Or you can say, this is brilliant. I've got these people's attention. I can talk with them, convince them that I'm a reasonably good person. Like, we're all going through the same struggle, right? So there's that bonding element, right? And then when you leave here, you're all going to have this, like, well-developed social network of data scientists who are operating in wildly diverse fields. That's amazing, right? You can leverage that. And so I'm not accidentally trying to force you to talk to each other. It's because I want you to, like, talk to other people. But I don't have an infinite amount of time, and so I have to, like, chop you off. But I do want these conversations to continue outside of the classroom. So hopefully, after many, many conversations with all the people in this classroom, you'll start to know, like, oh, I like this person. We should talk more, and then, like, have those conversations. So that's the goal, right? Not just to talk about the essay. All right. So this is the schedule. We're going to have some classes coming up. During all these classes, the background sort of thing that's happening are these projects. So there's 3 projects. And so the first one basically, like, starts now, right? So, like, I'm going to try and give you a little bit of context, and then you'll ask me questions, and you'll sort of get nervous, and, like, there's a project, and, like, the tension will build, and that's totally normal. Okay, so basically the way that I work projects is I say, go off and do good things, and then I hope that you do good, right? I try and check back in with you, and so, like, I'm going to have you write a proposal, and the proposal is, I'm going to do this thing, and then I'll look at that and say, like, that's totally reasonable, that fits your skill set, sounds good, proceed, or maybe we want to work on this and revise, right? So, like, your first submission of your proposal doesn't have to be the end. It will be the thing that I grade you on, right? But it's maybe not the thing that I bless as far as, like, moving forward. Okay, so once you've done your proposal and you say, I'm going to work with this data and answer these questions, and it's totally legal and it doesn't cost any money, I'll be like, sounds good. And you'll go off and you'll do some Jupyter notebook-based analysis. So that's the part where you'll put your skills to work, right? So we're developing the skills in this class. I realize that. Not everybody's at the same pace or at the same point. So I'll take that into account when I'm analyzing your work. And then some of you will be giving an in-class presentation. There's 25 people. I can't fit all of you into 2.5 hours. I've tried that. It just doesn't work. So the way that I've sort of developed this by randomly selecting you for a presentation. The consequences, you have to do the work, right? You have to do the work, get the presentation prepared in case you get called. Because you don't know whether you're going to get called. I don't know whether you're going to get called. I make the decision in class by using Python to randomly select from a list of names. It's kind of exciting. All right, so I get to... How many? That depends. You're a gambling person, I can tell. Yeah, so there's like, I forget, it's like 10 minutes or something per person, so 12 people, 50%. And then I try to weight the bias towards making sure everyone eventually does participate in the presentation part. So if you present during one project, you probably won't be selected for the second one. Can't guarantee that though, so. All right. Like I said, this is sort of like free reign as much as I can make it. So you are going to pick the data source that you're doing analysis on. That means you get a lot of choice. Yeah, I'm not going to force you to figure out which data set is right, but you're going to come back with, I think this data set fits my skills and the questions I want to ask of it, and I have some experience in asking those type of questions of that data. Right? So if you've worked in healthcare for 10 years, that's cool. Maybe you'd want to explore some healthcare data. And I do provide a list of potential data sources. They're not exhaustive, right? There's tons of data sources on the internet that I don't know about, and I love learning about those through my students. Yeah, so I'm not going to force you to like do that discovery process of data, but if there's something that you don't see on the list, come talk talk to me and I will help you search for that. So I can help you search for data. I'm pretty good at Google. Yeah, and lastly, like you should have some knowledge of the data you're looking at. Like if you've played online games, you shouldn't try and evaluate online game data. It's just not a good match. Okay. So then what am I looking for, right? So as I sort of have sketched out repeatedly, I want to challenge you so that you learn something. How do I do that? Well, I try and match up like the complexity of the data, the type of questions you're asking, and your skill set. So I give them that's totally subjective, and I understand that. So it's our balance. Then your report, it's not a PowerPoint, it's not a PDF, it's not a Word document. It's just your Jupyter notebook. And you're like, Ben, but the Jupyter notebook only contains Python code. I was like, no, it can contain writing and pictures and like all the things that you want in a report, but it's dynamically generated, which is cool, right? I mean, like, I saved you a bunch of work. You don't have to go write some giant essay. You can just write a Jupyter notebook. It's much better. I'm a little biased, though. All right. So yeah, then obviously, like you should apply what you've learned in class. You can also apply things that you have not learned in class, like from other classes. That's cool too. I probably won't be as strong a grader on that, but I do. This is like my one thing that I really get antsy about, but I can't teach it very well, which is visualization. Like I can tell you this visualization looks appropriate. It's intuitive to understand from each perspective. I can often pick out like technical points of your access should have labels. You know, your units should be present in the visualization. I can't tell you what visualization is, but I can give you technical tips. This is a hard thing to teach. We'll try and cover that. All right, so that was sort of like the future, but now we're going to be sticking to this class. Oh, sorry, I should ask. Does anyone have any questions about projects? Yes, April. Yes, those are laid out in Jupyter, so in Blackboard, as far as the number of rows, number of columns, number of megabytes. Well, so the upper bound and lower bound, like it shouldn't be too big or too small. Those are laid out in the rubric. The due dates are also in the rubric online. All solo work. So all of the assignments, all of the projects, they're all solo. But that, by the way, so I should leave a comment. So that's not an accident. So like I know in the real world you'll be collaborating, and there are aspects in this class which I'll try and help you work on your skills of collaboration. But the assignments and projects are not where I want to see that, because I want to understand where you're at as an individual student. All right. So what are we going to cover tonight? Basically, the very intro concepts to Python, things that I would consider fundamental. So lists and dictionaries, we'll spend time on those. Functions, why would we use functions, right? And decomposing complicated problems into simpler things like functions. Yeah, okay. So by the way, these are all words. Some of them are blue links that you can click on with the slides. When you click on those in Blackboard in the link, then you'll get access to the slides and you'll be able to click on those. If these are words that are unfamiliar, that's cool. This is my warning. I can't teach you Python in 2.5 hours. That should be hopefully apparent to everyone, but do not walk away from this class thinking, man, I didn't understand Python. Why didn't Ben deliver that in 2.5 hours? Like, I'll try, but I'm just not going to be able to do it. So with that said, there's tons of other resources. Python is like one of the most popular programming languages, like measurably speaking. We can measure that. And it is very popular. It's widely used in a bunch of different domains. Lots of people are trying to use it for different problems, which means there's tons of tutorials online. Obviously the online courses. You can talk to me. I use Python occasionally. I should say I'm not a programmer, right? So as I mentioned first class, there's this thing called imposter syndrome. How could I possibly, I've never taken a class in data science. Can you believe that? I've taken one programming class 15 years ago in college on Java. I failed it. Like, how could I possibly be teaching you? Right? This is like my imposter syndrome, right? I don't feel it too much because I'm pretty confident, but this is the thing that you'll have to wrestle with because you're working so many different domains. Okay. All right. So first, I'm going to scare you. This is the part where you get like anxious. Right? This is we hook you in, right? So if you've spent any time reading about data science, you've probably seen some of the words up on the screen, and it's super scary. There's so many tools, right? How could I possibly learn Python, R, Hadoop, Spark, SQL, TensorFlow? Like every day, you learn about some new language, and you're just like, I'm so far behind. Right? Does anyone have that feeling? Okay, a couple head nods. Good. Not just me. Okay. So what do we do about that? Right. So there's this intimidation factor. There's fear of not knowing all the things, and it looks really bad when you like show up for a job interview and they're like, you know, this, and you're like, I've heard of those things, and like that's just a bad thing. Right. So this actually has some consequences besides just not doing well in interviews. Like if you talk to other people and they're not using the same words as you, it becomes really hard to communicate the problem you're trying to solve. Right. So like there's just this exposure issue. Not to mention the really fun part I like about programming, it changes how you think. Like if you learn C and Python and awk, like those will affect how you think about problems. That's pretty cool. But if someone else doesn't have that same language skill, it means they can't think of the problem the same way as you do. It makes it really difficult to collaborate. Okay, so in this class, the way I solve that problem, I just throw all those out the window and I say we're going to focus on Python. And Python 3 has been around for 10 years. It's a very old language. It's really stable. Has all these positive features, right? But I didn't tell you this lie, right? So like, there's all these libraries, which it's almost as bad as having to learn all these languages, right? How could I possibly be exposing you to hundreds of thousands of Python libraries? Right, terrible. So this is like, even if you down select to one language, you still have lots to learn. And I can't solve that problem either. Right, so for those of you who are experienced programmers and you're totally bored by this talk, there's a little challenge for you here at the bottom. Like, try and tell me how many packages there are in Python. Right, so it's a hard problem. Not too hard, but. All right, so for the rest of you who are paying attention because this is a bunch of new stuff for you, there's a bunch of words. Right? And I apologize, some of these words are used in different contexts to mean different things, even though it's the same word. And that's going to be super annoying, and it's just like life. So I apologize. I won't try and read these to you, but they're basically things that you may want to gain some familiarity with. Besides just talking to people, like when I'm trying to search for something in Google, it really is useful to know what the language is. The words in the language, I should say. Right, and then if I misspeak or like say something in gobbledygook, you should definitely say like, Ben, what are you talking about? I like being called up. It's fun. All right. So we just talked about a bunch of libraries. The good thing is you don't have to like go out to the internet, download all these libraries, source code, compile them into like binaries and like do all this work. There's these things that do all that library management for you. It's really handy. So there's two package managers. One's called Conda, and the other one's pip. So Anaconda, if you've installed that on your computer, you'd sound familiar. Basically, Anaconda uses the Conda package manager. They're all sort of naming the same thing, but the library management software has a name, and that's what you'll probably be using to do all your library management. I use pip personally. It's slightly more complicated, but that's a historical accident of using pip before Conda existed, so I'm stuck in history. Right, so why are we wasting all this time on libraries where we could just write our own code? It'd be much easier. So the advantage here is I want to strive to make you lazy. Lazy is so good. No one has ever told you that, right? But laziness is so beneficial. It means you can be efficient. You don't have to work as hard. You can go do other things, right? All this by leveraging the work of other people, right? You don't even have to credit them, right? Like if you use NumPy, you don't even have to call out, oh, thank you for all the NumPy developers. I mean, you can do that. They take their money, but if you want, but you don't have to worry about that, right? Like you can just leverage all this work that's been done before. This is a sign of a good programmer is they know when to use a library, and they know which libraries generally are relevant. We'll come back to this slide over and over. You'll get tired of this guy probably. All right. So now we'll actually use Python. What does that look like? Yes. So I would say, well, let me not self-inflict. So I think of a package as like the actual software file. I mean, that's just my personal use. It's sort of interchangeable, library, module, script, package. It gets kind of washy. I mean, like, so we will show you in this class how to write a script that is loaded as a library, or if you want to think of it, you could package it into a thing that's used with people. It's very mushy. Sorry for the lack of clarity. Exactly. All right. So I posted a video on YouTube. I don't know if anyone watches those things. I mean, there are metrics, but I don't know who watches it. So posted a video on the different ways that you can use Python, and we'll be doing those things tonight. So if you watch the video, good on you. The way that people used to use Python back in the day before Jupyter was they would have this command prompt window. And if you've never seen a command prompt window, you probably won't see too much of it in this class. We'll try and expose a little bit on this class, but more often you'll see Jupyter notebooks. The two ways with the REPL is you can write plain Python in the browser and then the command prompt and get an evaluation back immediately, or you can use Python scripts to contain your code and launch those either in the command prompt or in Windows with just double clicking on it. Okay, and then you can even mash together Jupyter notebooks to use Python scripts, and we'll show that. So there's all these different ways, and it gets really confusing for new people because they're like, what's going on? Like, there's all these different ways to interact, and like in your head, you don't have a good model yet of what's going on. So I empathize with your struggle on disentangling all these different ways of using Python. All right. So first, we're going to look at the Python REPL. If I can pull that up. All right. Let's make a new console. Python. There we go. Python. All right, so I just opened up a Jupyter notebook, then I entered a terminal, and then in that terminal, I opened up the Python 3 environment. So now I have these 3 arrow signs. That's my Python prompt, so I can type things in. Make it a little bigger for you. Okay, so I'm going to show you what a list looks like. So I've got my list, 4, 5, 7, 9. Okay, so if you can't see this, just raise your hand and we'll make it even bigger. So I've got a list. I'm using these square brackets just denote the beginning and end of a list, and I've got commas to separate elements of a list. Those are like the 2 major factors, right? And then I'm taking that list and I'm assigning it to a variable called myList. So far, so good. Pretty straightforward things to understand. Now I've confused things a little bit. I have elements that are both integers and a string. So I can mix variable types within a list. And that becomes pretty powerful. So basically, when you're solving problems and you want to keep a set of things, maybe you want to put them in a list, and then you can access them. So let's do a myList 0. All right, so this got us back to character 4. And as I mentioned, that's because Python indexes lists by 0. So it starts off 0, 1, 2, 3, 4. So the 0th element is the value 4. All right, now this is where we sort of get off into crazy land, right? So I've just typed the word LEN and then some parentheses. You're like, Ben, what does LEN mean? Well, it means length. But how did you know that? That's the hard part, right? So how do I know that LEN is length in Python? That's because I've memorized it, right? So like the bad part here is like memorization is just part of learning languages, right? So I have to learn the vocabulary. So the fact that LEN is a thing that measures the length of a list and uses parentheses to take an argument. These are all things that I've memorized. So just a heads up. Okay, length of the list. Oh, list. Thank you. All right, so there's 5 elements. Even though it goes 0, 1, 2, 3, 4, there's 5 things in it. Okay, now I had one type of exception already, so let's do my list of 12. Okay, another error, right? So every time that I type something in my command prompt, and Python's like, that doesn't make sense. I don't know what to do with it. And it'll return an error message, and I'll try and say what the type of the error is. So here is a name error because this variable doesn't exist in Python's list of variables in its working model. And then here, when I typed in my list 12, I get an index error because Python doesn't know how to access the 12th element of that list. Okay, so basically, when you're typing this, you'll invariably run into problems, and you'll have to learn how to like decode this language. So the way that I start is I always go to the bottom, I like that bottom line. And if that doesn't tell me what the problem is, I work my way up. Right? So if this wasn't making any sense, the context is, oh, it came from the standard in, so that's like the part where I was typing. In line 1, obviously there's only one line, so that's easy. In the module, so if I can bring in environment. So work your way up from the bottom, look for this keyword to be like the type of error that you're having. Hopefully that provides hints as to what the correction that you should make will be. Okay. Oh yeah, so one last sort of like scary aspect of Python. So let's do my list 0 equals 3, 5. Okay, so I just created a new entry in the 0th element of the existing variable that is a list. Seems reasonable, right? Now let's look at my list. It is a list of lists, right? And so that's cool. But the bad thing is, it didn't warn me that I was overwriting that element in the list. There was already a thing there, and I just overwrote it. And Python's like, that's cool. I'm doing orders, right? So like, sometimes you want that, and sometimes you don't. And like, you'll be confused as to like, what does this list actually hold? Well, I'm going to need to go back and look at it. So this is the part where, like, for instance, when I'm running through your notebooks that you've submitted, I often like to like insert a new cell, see what the variable actually contains as you're executing your notebook, and like continue execution. So I get value out of your notebooks being broken into cells because then I can insert and check like what's the actual content of that variable, because maybe it's not what you think it is. So it's a suggestion that if you're confused, why is this program not doing what I thought? It's worth sort of inserting a break, checking what the value of the variable is, and then moving on. Yes. Okay. Right. It's in the slides. All right. Oh yeah. I should also mention like sort of the straightforward stuff of it does the things you'd expect it to do. You can pull that up. Yeah, so the things I show you was like if I type in 5, it just returns 5, 5 plus 4, 9, right? So all the things you sort of expect. So those are all good things. But all right. Right. So now I'm going to go on the dictionaries. Dictionaries. So we just covered list and scalar values, and then I'm going to show you what dictionaries are. Dictionaries are to me the more powerful thing that really is useful in Python. Linked list is another name for them. I'm just going to name it my dict equals. Okay, so this is like the essential components of a dictionary. I've got a variable name assigned to this thing with curly brackets, so unlike the square brackets before. And now I've got a thing separated by some colon, where this is a thing and that's a thing. This is the key, that's the value. And now the tricky part to know about, like all those aspects you just have to memorize, right? And there's one more thing that's really important. This thing called the key that has to be unique in the dictionary. So what does that mean? Well, I can access the key, my of 4, and it returns the value. So if I have a key, I can get back the value. That's sort of like the utility. If I add in more elements, like let's say 5 and 6. Okay, so the reason that the keys have to be unique is because I wouldn't want to have to like try and figure out which key are you talking about. Like this there has to be unique. You can have repeated values, but the keys have to be. Okay. And then, so let's see. Right. So if I type in the 0th element of a dictionary, anyone want to make a guess? That's not a thing. Sorry. So if lists have indices, places where you can find values, dictionaries do not. They only have keys. So if you're really silly, you could make a dictionary where the key is 0, 1, 2, 3, 4, 5, 6, right? And be like a list. All right, you wouldn't want to do that. All right, I'm not sure. Yeah, so let's do a little bit more complicated thing. So let's put a list as a. All right, so now we can do mydict of 5. By the way, you'll notice here I'm being a little silly. I have a key here that is the string 5. So this is different than the integer 5. They look the same, sort of, except for those little tick marks. All right, so not surprisingly, I can get back a list when it's the value for a key. And then let's go real crazy. I mean, like, it's out of this world. All right, so we've got Ben, and then is, and oops, what else? Everything. I misspelled it, but let's move on. All right, so now we've got a dictionary containing a key which has a dictionary as a value. All right, so your mind will be like, all right, how would we get to that? So mydict of Ben, right? That is the dictionary. And then we can get to a value in that dictionary by saying like another, so that's like a nested dictionary. All right, so we can drill our way down. We saw this before with JSON, basically treating it the same idea as you can nest structures, just like we had a nested list, so we can do nested dictionaries. You can have dictionaries that contain lists. You can have lists that contain dictionaries. I mean, it's like the complexity is there, even though we've only done like 2 things. So that's kind of like the power of programming is like breaking that into something useful, mapping onto your problem, solving the problem. Like that's where the fun is to me. Okay. Right. So we did that. Oh yeah, I should say. Well, yes. Question. Like that? Like a list? No. Lists are not. So the technical word is hashable. Lists are not hashable. There's not a unique representation for the list. So I think what you're saying is like test. So what kind of key would you want? Like a key, a list? Yeah. A list of lists? Hmm. I'm not clear on the question yet. Yes. Yeah. No. Okay, try me. It can have multiple values. Yes. Yes. Yep. Yep. Yeah. Yeah, you can have a list of lists. Right. So like let's say I go back to this example where my list is 3, 4, and I could have another list like I don't know, Ben. Like that. So the 0, so like my key is dates, right? But then my 0th element is the list 3, 4. And the first element, because it's index 1, is Ben. Is that what you were seeking? Okay. Yep. Okay. So you're like, Ben, I'm super bored. Why don't we do an activity? Great. All right. All right. So now, if you don't have paper, I will give you some paper. You don't here need paper. We're doing an activity. I'm walking around not to see like that you're doing it right. Just like the last question and drink your not for Alright, so let me, if you didn't see how to make a REPL, I'll show you how to do that. Okay, so over in your Jupyter Notebook, if you see this type of thing, sorry, if you don't, you should click on the plus sign. It'll say new launcher. That'll get you this launcher window in a Jupyter Notebook. And you can scroll all the way down to terminal. Click on terminal. And once you're in that terminal, you should be able to type Python 3. And if you can't get to that, let me know. Yes. Because most people in this class have never been. So yeah, this is merely an exposure so that people know, oh, I do. Anyone else questions on Python? I would recommend you go back refile. This is setting Python. Now you're in the terminal. a little different environment. Yeah. Yeah, the browser thing, that's Jupyter Lab versus old Jupyter. So I think if you're using Anaconda, you should have places like Jupyter versus Jupyter Lab. This is the Jupyter Lab. Yeah.
What I wanted to do. I mean, that's
It should be an Anaconda.
I would like.
Question? Okay. So not everyone here has Jupyter Lab. You do if you have Anaconda, just select the Jupyter Lab option. That's what I'm using. Yeah. And if you're in Windows, Python would also work. All right. So I'm going to go through my exercise. My meals equals fast. I have some pretty bad meals. All right. Let's make a mistake. So you should be able to hit the up arrow key, and that'll get you to your previous command. Yep, that's the terminal. Okay, so the point of the exercise, if you haven't completed it yet, was to make something that looks like this, where keys and values are the thing that you're working with in a dictionary, and then you can access the contents of one of the keys, showing you what you ate for that meal. Maybe you didn't use breakfast, lunch, dinner, that's cool, but that was the goal. So I don't have any questions on that. Okay, so I think now we'll take a break. We'll come back 8:08. And that, well, 9, how's it? 8:09. I meant to aim for 5 minutes. Question? Okay. So I try not to look at the email while it's recording, but I will, actually I can do it on my phone.
Yesterday night, I think.
Okay. How do you spell your name? This one. Right. Machine learning question?
Yeah.
Okay. So what did you want to ask? Is this the one?
Oh, what? I'm talking
It's at 5:54 a.m.
Oh my god. I was wondering if I did.
Yeah. Okay.
Okay. Thanks.
You're welcome. Okay. 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 Can I revisit after class with you? Okay. Exactly. Okay. We can review. Okay. You're welcome. Question? Absolutely. So you can add a new key to the dictionary. Yeah, so I don't know if I have time to show that here while everybody's coming back. So let's say that's my key value. The way I would throw on a new thing, so let's say 1. So value. So I had a question during the break. If I have an existing dictionary, how do I put new things in it? So here I created a key value pair with KV, and I'm going to add in a new key value pair like this. So now if I look at my dict, it has the 2 key value pairs. Is that what you're asking? So I think it's not in this lecture, but in a future lecture, we'll actually get into mechanics of seeing how Python does that. So we will understand what it is that's going on in the background. It's not using list indices, but it's a little more complicated. Yeah, so it can do my dict of k. It just silently overwrites it. Yeah. Oh, yeah. It overwrote the value, not the key. Is that what you're asking? Okay. All right. All right. So here's a bunch of things that we'll talk about in class. I will sort of assume that you understand, which is a bad thing on my part, but I just have a hard time diving into all these things at the appropriate granularity in 2.5 hours. So I'm going to rely on you. If you don't understand loops, like for loops, while loops, if-then statements, all these control statements, these are things that you will have to pick up. I'm not teaching you all the details of Python, and I apologize for that, but hopefully through lots of exposure, you'll see things and be like, oh, that's how he's using a for loop, right? And the Jupyter notebooks that I use in class will be posted in Blackboard, so you can stare at those to your heart's content. The videos will be online from lecture, so like, you know, it's not for a shortage of material, it's just like time it takes to learn Python. So you will not probably leave here, if you're starting from scratch, you will not leave this 601 section a Python expert, guaranteed, right? I'm not a Python expert, it's cool. Okay, so these are the things that you should have some passing party with. You will need to use each of these in your projects and in your assignments. So these are things that I really encourage if you're like, what is he talking about? If else, like, what is that? Like, these are worth learning. Okay, then a thing that is a little harder that I'll spend a little bit of time on is the concept of a function. If you haven't seen this before, it's probably new. If you're new to programming, functions are things that like we as programmers talk about and like we sort of assume everyone knows, but I've learned that's not the case, right? So like a function is basically a thing with a name. So here it's my func, and it takes an argument, we'll call it the input, and then returns a result. So it's similar to a mathematical function. It typically applies transformations to your inputs to get the outputs. That's why we call them functions. It is related to math. In Python, we use this keyword. This is a reserved keyword, def. That means we're defining a new function with the name that we specified here. Now, functions are a little bit complicated because they can take no arguments, one argument, a list of arguments, right? And so then the return statements can do the same thing. The return statements can return nothing, one variable, a bunch of variables. And so you can sort of see like they're useful in the sense of like you can wrap up a bit of code and then call that function for different inputs. And then hopefully you'll get different outputs usually. Like you're applying the same snippet of code to do a thing, typically on different inputs. And there's sort of a couple different ways of why you'd want to use a function. The primary one to me is if you're doing the same thing in code over and over, and you just want to call that same snippet of code over and over, wrap it in a function. That's like the pretty straightforward use case. The reuse code, that goes back to the laziness principle. Laziness is good. I don't want to see, like, this is a bad one, warn against this. If you have a piece of code and you want to use it over and over, do not copy and paste it 10 times. Right? That is a not lazy programmer, that's a bad thing. Why would that be bad? It's because you have the possibility of introducing bugs, and you have the bug repeated 10 times, right? Or let's say that the loop has to go from 10 iterations now 50 iterations. You're just like, oh my God, there's so much copy pasting, right? So use a function to wrap up little snippets of code. The other way to think about why functions are useful is because they have this encapsulation concept. They take an idea, they put it in a little snippet, and then you don't have to worry about it. Like you set it aside, you can apply that function elsewhere in your code, but conceptually in your head, the thing that it does is now wrapped up. Like you can treat it as a thing. And that's where the real power of programming comes in, because now you can use that on different inputs and different outputs elsewhere in the code. And it becomes like this working tool that you can apply, right? So if you want to do an analogy, it's sort of like you're a carpenter, you're building your own tool set that you can use to do other projects on. So these functions will develop functions that I would say are useful outside of class. All right. So let's do, I was going to show this. Pull up Jupyter. I'm going to get out of this and make a new one from scratch. Right. So the thing that trips up people in functions is that the scope of a variable is constrained to be within that function. So those are a bunch of words that are specific to programmers, and I apologize if they didn't make any sense, but I'll show you what I mean. So let's get a new variable, call it a equals 5. I'm going to define a function here on the fly. That's pretty exciting. My func of input. So observation number 1, I'm indenting 4 spaces. All of indentation in Python should be 4 spaces. This isn't just me speaking, it's like a standard. I'm going to say e equals 5. And then within the function, we'll print the value of a. And then we'll close our function with a return statement. And we're not going to return anything. It's just going to return nothing. Okay, so now you can see I've switched from these triple dots to these triple arrows. It means I was writing something that had indentation. So all of this code you can think of as like being associated with this one line, even though it's on multiple lines. But here, all of this is one snippet of code. So question to you, now if I print 5, so print a, I totally missed the point on what I was trying to do. All right, let's try that again. So def equals 6. That was my point. Apologize for that. I'm using the up arrow to get back to my thing. All right, so I had a equals 5 outside of the function, and then I have a equals 6 inside of the function. That's what I meant to do. And now if I run the function, well, right, I get back 6. But now here's the wacky part, right? Woo! That's that word scope that I was talking about. That's the implementation right there. So we have this. I can't see it quite. I made a mistake. So up here we had the variable a equals to 5. In the function we had the variable a equals to 6. Now we've got print statement, we get back 6, but then when we look at a is 5, all crazy stuff, right? The reason is because this variable was only defined within this scope. So within that function, a variable, even though it had the same name. So you can, the way that my conceptual model is like, there's an a for this function and there's an a for the global, and you want to keep track of those as separate entities, even though they have the same variable name. It's an implicit sort of idea. Questions on why I passed hello in as a string? No. No, you can have my func. So I didn't even put a return statement in there. Let's do my func. So you don't have to put anything in as an argument, and you don't have to even have a return statement, because Python is interpreting this as there were no more indentations after this, so the function stops. So I like to be safe and put a return statement at the bottom of the function just to be super clear that the indentation didn't get screwed up. That causes problems. But okay, so that was my introduction to definitions for functions and scope. Those are pretty advanced concepts if you have never heard of them before. So, all right. Question? Yes. Yes. Now, so what you're asking is a very good question. I'm going to restate the question. So I define, if other people are talking while I'm talking, it's harder to hear. So I'll wait. Okay, so the question was, I didn't specify the variable type, whether it was a string or an integer or a float or a dictionary or a list. And so Python, I get confused, there's like duck typing. Basically, this is like implicit typing. So the function didn't specify that it should be an int. You can do that as a hint to say like I expect ints as a check, but most of the time you're relying on the function to say I think this is an int. I'll behave as though it's an int, and if it's not, maybe I'll throw an exception. So like if you try and index an element of a list that's not present, we also don't do balance checking. Like we don't say like the list, it has to be a list and it has to be a size 5. Those are things we typically don't do in Python. So it's unsafe, you could say. Yes. So in my lazy function with no input, I'll do another print statement. No. So typically I would close a function with return even if nothing is being returned by the function. But more often, what you'll see is a function that does something like, let's say, a equals 5, and return a. Okay, so now if I call my func, it's going to return the value. And typically, the computations that you're doing in here, they'll be operating on the input to produce the output. And those outputs are returned to the user that way. But to be more useful, what we typically do is we store that output. So let's say the output of the function gets stored into a variable called b. And now that value of b is 5.
Well, easy compared to what, by the way?
Okay. All right. All right. So this is what we're after. But again, if there's people talking, I will stop and wait. All right. Questions on function? Yes. Are you saying can you? Not. I think not in the arguments to the function. Within the function body, you can say if it's not of this type, cause an error to occur. Yeah. So the testing of that, if you really do care about it not being a list versus a string versus an int, you'd have to do that testing within the body of the function. So I think what you're after is like, can I type something that looks like int? No. Yeah. So the answer is typically no. We don't do that. There's some safety checks that people have started building in, like if you really want to force that behavior into Python, you can do that, but it's not the default. Yes. Yes. I'm going to defer that to offline. I will follow up after class. But these are reasonable questions about types. So I will follow up. By the way, if you really do have something to say to your neighbor, open a chat window and just type it in. It's way easier. Okay. So I warned you that we're going to be looking at the console, the terminal. We just did that. We've been using the Python notebooks, and we will be if you haven't already. The third thing that we do is use Python scripts. These are files that end in .py. Python. And so if you're editing these, you need a text editor. Has anyone here not used a text editor before? We will find out if you have not, if you didn't raise your hand already. So you need to see file extensions. You need to be able to edit plain text files, because we're going to actually just create Python scripts. Okay, so for this activity, you should pair up with someone you haven't worked with before. Getting up, talking to people, finding someone new. I explicitly have not told you what the task is yet, so don't worry about that part. You can. If you know that person, you should find him. Okay. I'm assuming the people who have not gotten up have found a partner. Is that valid? You guys are good? Okay. If you haven't worked together, that's good. Okay. So, with your partner, have you found a partner? Okay. You might need more space. That looks like maybe.
So even if you know how to do this, I actually do want to see it. No joke. If you can do the print hello statement and then PY file, I just want to see it. Yes. So this is hello.py.rq. That doesn't have the file. You get half. Now that file is in Python script. So the contents. So the contents of the file actually
Well,
that's an actual content. Yeah. So you want to play Python. Questions? You got questions? Yes. Awesome. Good. Good.
we don't have to.
Awesome.
No, I mean. So, I mean.
So what we did, I used my notepad just to type this book, and then I saved it as a file document. And then I just Word.
Now you're in the
So what I'm doing right now, I'm doing, no idea. Yeah, I have no idea what
you're in the terminal. This is like your operating system that has two things. This is the command line prompt with your operating system. You're netting through Windows, but it's in the command line. And so you're using the DIR command to listening. It's the same thing that we're looking at here. And then we use the command Python to launch the interpreter against this command by the interpreter.
So if I don't put Python,
It would not. So it's like, right. So you probably have file extensions. So it's actually probably Python. Although nothing you find out. You can see probably. So now I would exit from here. Exit from exit. Now you want to CD space stuff. Anyone else? Questions?
Yeah, there wasn't one when I was here.
I will come back. Okay, so if you had questions on this exercise, that's totally fine. The whole point of this was to expose you to the terminal, and now you're using Python scripts.
This is like your one, probably only exposure to it. We may touch it later in class, but basically this is just to say now you've exposed yourself to the terminal. That's good. Okay, then I will back for those of you who had questions after class. Does anyone have any questions they want to ask now? Okay, so let's come back to our seats. One time. All right. All right, so we're going to resume. So this is a challenge that I have. You guys typically don't want to start talking when I assign an activity, but at the end of the activity, you don't want to stop talking. That I have not come up with a solution to, other than like a whistle. All right. Thank you for participating, by the way. I do appreciate that. So just to reiterate some things that you've probably already seen that will trip you up. Spaces, do not use tabs when indenting. Like I see that a lot. It causes problems I'm not going to get into right now, but tabs are not equivalent to spaces for indentation. Okay. Type definitions we've already touched on, and we'll come back to outside of class about types. Indexing from 0. And then if you really want to be fancy and you're working with like a large group of developers and you don't want to look like a dummy, you can use what's called a linter. So a linter is a program that reads your code and looks for mistakes. That's super handy. So it basically allows you to say, this indentation was 3 spaces, you probably meant it to be 4. This variable name isn't consistent with anything else in your code, you should probably want to remove it, right? So like it goes through your code and looks for problems. For the scale of code that we're writing in this class, probably not that useful. But outside of this class, when you start writing larger Python programs, linters are definitely useful. They keep the consistency of the stuff, which makes it easier to read. Okay, so we're going from activity to activity, right? This will be it. So I've thrown a lot of words at you so far in this class, and I haven't given you a lot of definitions. So that's what these are, words and definitions. So we'll do this activity, and then we'll take another break, and then we'll wrap up class. So again, we're going to look for partners we have not worked with. You will not need your computer, so you'll want to like clear space on your desk because you need lots of space for this exercise. So find someone you haven't worked with. I'll distribute these, and then we'll get into what's the game. If you need more space, come to the front. That's also a good idea. Find a partner you have not worked with yet. If you know them, you're wasting your time. Partner. Partner. All right, so here's the game. You've got a stack of papers. There are a bunch of clips holding the papers together. I'm really poor, so I need these clips back. So when you're done with the exercise, we'll want them in paired order. So you have a set of words, you have a set of definitions, and what I want you to do is unclip all of them, put them in paired order, and give them back to me. So think of it as a matching game, where you don't know what the answer is. Are they ordered? Then you should definitely shuffle them.
Sorry, if they're ordered, I
You guys got more? Some of them were shuffled, some of them were not. My sincerest apologies.
So why don't we put the
Have you shuffled? Have you heard the words? Yeah, the goal is to have them shuffled. I didn't shuffle them. I bet. If you have them ordered, just shuffle them. I bet.
it's got like a final experiment. Got the chain.
Wait, aren't
You have to learn in order to be late. You were making more work.
Match. Let's start from easy. Very well. No, this is documentation. Well, I think I got some comments, information, that's reported on got that. That's probably the valid. Alright, I guess, yeah, that's something. Let's put it like this. We're not so, what's local variable? It already says the local variable. It's not great. Okay, that's not tricky. Yeah.
Good.
Go on break. Absolutely. He was your friend, man. Awesome. How could tell? The whole process of elimination. Well, yeah, I guess. There's the like so yeah, the arrow is programmed down. Got it. Yes.
I don't have time. I would just say that you can go on break, or you can help others.
Yeah.
When you're done, hand me back the pair and then help other students or go on break, your choice.
Thank you. Thank you. Did you find your JSON loads problem?
Yes, sir. The difference between loads and dumps.
Yeah, so I see. So JSON loads, like reads. Yeah, so going back to the JSON notebook from lecture 1, what was the, so like you have to, the JSON library reads in JSON and produces JSON. So what's the question?
There was a statement. It was JSON dot loads and JSON dot dumps.
Okay, so maybe I will pull up that notebook after class. Okay, but I'm gonna help.
Yeah.
Okay.
Yes.
So let's come back from break 9:05.
Oh yeah. All right.
You guys are working through pretty hard here.
This was serious.
Yeah.
You want us to shuffle it?
No. So this is the problem I ran into with the distribution. So after you hand all of yours back, then I will have to go through all the pairs, make sure that everyone has the right pairs, then shuffle them, then hand them back out next time. So if you hand them back in order, it will make my life easier. Well, it's 20. Sorry, it's 25 students, so I have 13 pairs of sets to go through. No, it's just one foot. Got it. Okay, go ahead. I will check in. Got it? Thank you. Huh? Cheat?
Absolutely. So you guys are really working hard. The one lady. Oh, I see. Nice.
heard the definition, but not as like really circle as.
Right.
Okay. No, that's the project.
What the
The
hell?
case study.
You didn't see anything.
This is not the case study. This is like basically like the method. This is
No,
science
this is
or sheets.
There's also
So-
strategies for like counties and stuff.
Well, I just started reading it today.
No, that's right. I'm telling you, put money on that one. I don't know many of these, that I know.
Started and I just write the first sentence. Yeah, my first sentence. Oh, yeah, right. Please say that class is not. That would be like that would be specifically for the somebody else way are they so you go to for things. So one thing is the special they don't have any and then of course
If you're still working on your pairs, hand them back to me. I will take them. I need the pairs back. We're gonna resume class in like 30 seconds.
okay. So yeah, so basically
Well, that's probably correct. It was unsolicited.
that's what I'm referring to. So the
Okay, please return to your desk if you're not already at your desk.
So if we're returning these, would you like us to
In
come up again?
No,
for
in
your
paired order, with the clips. Okay, so we've got hypothetically 35 minutes left. I've got way more than 35 minutes of content, so I'll try not to speak quickly, but we would like to get started. So for the purposes of brevity, I'm going to skip over this list. You can sort of, yeah, thanks. Okay. So does anyone here want to make a guess about what the answer to this quiz is? Okay, I'm hearing lots of fours, so we'll give it to the fours, and the answer is length of list, 4 elements. That's cool. And so if I ask what's the first element of that 4-element list? B. So Python indexes from 0. Therefore, the first element, 1, is B. All right, so that's why. So this is why we have the quiz, right? Absolutely, that's totally reasonable. So like element 1, 2, 3, 4, indexed by 0 looks like 0, 1, 2, 3. That's where it always trips people up. It can trip you up. So yes. All right. So what have I covered so far? Just to like recap, this is in your head. I'm now going to move on, assuming that you know all this. That's the dangerous part, right? So I assume you understand JSON, CSV, XML, the terminal, the command prompt, using Python scripts, data structures, right? That is a lot. That's a lot. No joke, right? Okay. So I'll try and sprinkle in these little tips here that like don't fit anywhere, but they're just kind of cool. Okay. You can see like we're halfway through class. We've got 35 minutes left. All right. So I like to talk a little bit about Jupyter and why we're using it. It does get used out in the industry. I use it a lot in my work. And these are just some news articles that advertise big companies using Jupyter for important hard problems. I see these as outliers because that's not how Jupyter is typically used. Like it's cool that they can do that, but it's sort of like an edge case that you probably don't want to wander into. Most of your Jupyter use will be for small scale data analysis, exploration, not in production. So that's typically how Jupyter is used. The other things, there are issues, like Jupyter is bad in some sense. One example of that is you can run this cell, then the one that follows it, then the one at the bottom of the notebook, then the second cell again, and the third cell, but then the first cell, right? And that's a problem. Right? The problem is maybe I have a variable definition at one point in my notebook in one cell, and I have a different definition somewhere else in that same notebook, and I can overwrite the definition. And with that out of order execution, which that's why Jupyter notebooks are handy, it also causes a lot of problems. That's like probably the major issue. The way I solve that is I use a lot of going to the notebook. Let's open one up. So there is a really handy button that I use all the time. So it's let's see, kernel restart and run all cells. So this little key here, it wipes everything out of memory and executes all the cells from top to bottom. That makes sure that the cells are executable in order. Because often I see students who have like, so we'll get into this notebook, but like over here in this corner, you'll have like a number here. That's the number of execution for that cell. So I'll see something where like people have executed cells hundreds of times. That's not a bad thing. I'm just saying like that person has spent a lot of time in that notebook. So it's good that I'll occasionally go back and just restart and run all cells. It wipes everything. Make sure it's linearly executing. Okay. Right. So in addition to Jupyter, which there are complaints about, it's not perfect, we're also using Pandas. Again, it's really widely used as a computational library for data scientists. It is similar to the features that are in R. So if you go off and wander into some business that uses R, you should feel mostly at home, although the syntax is a little different. And we'll be talking a lot about data frames, which are basically two-dimensional data structures, like you'd see in Excel or a CSV. And then series, which are the columns that compose a data frame, typically. And then the reason, so Pandas didn't exist, and then like suddenly it came on the scene and dominated everything. The reason for that big shift very quick was because under the hood, it uses a library called NumPy. And NumPy is a super old, very powerful library that does a lot of math computations. But it was a little hard to use. Like it's very powerful, but hard to use. And what Pandas basically did is like wrapped up all the numerical computational power of NumPy and put it in this very easy to use format with a data structure that's pretty intuitive and powerful. And that's why it kind of grew up popularity very, very quickly. Okay, so with that popularity comes lots of documentation tutorials, all those good stuff. Right, so now we're gonna show what why would I use Jupyter Notebook? And this is like, I just like stumbling upon random data sets on the internet and like tearing them apart. It's like my job. So I'm not a big bowler person, but I have bowled before, right? That thing where you do this and then like things fall over. That's bowling. It's good stuff. So there are people who like, that's their life, right? They're professional bowlers. And there are conferences where professional bowlers meet. And there's champions and blah, 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 right? So like these people get together and they all have these like big conferences about bowling, if you can believe. I mean, that's just crazy to me. But and they have this like planned out to 2027 for where they're holding their conferences, right? Again, this is just mad. Okay, but then okay, let's not go to that pop-up. But so then you look down here and you're like, huh? Look at they have what's probably a year, right? But just that's a year. Then we have like a city and something like a state. That makes sense. And then you got this other number. Any guesses on that? Right. So it's the past year's attendance for the conference. All right. So this is where like now my data science spider sense goes off, and I'm just like, look at these numbers. They're all over the place. And then down here, okay, back in the day there weren't quite as many. Yeah. Okay. 1930. 1901. 41 people. All right. Right. This is a great data set. It's like it's got geographic diversity, got some clear trend, right? It's got years, time, a lot of elements that are super cool in data science, right? So time series analysis, geographic analysis, trend analysis, good stuff. All right. So now, like, okay, this is clearly lacking something. I want to plot and see what that looks like, right? What does that growth in popularity look like? I'm just kind of curious. So clearly, it ends at like 10,000, starts at 41. Oh, it's cool. Let's take a look at it, right? How hard could that be? So let's. All right, so I'm going to go off and see if I can get these in order. So the first thing that I did was I went off and I copied this data. So I just went to the web page, right? Me with my mouse, selected all this data. If I can scroll. And I copied it and I put it into a CSV file. So bowlingstats.csv. So Python loads that CSV. It looks like this. You'll notice there's a bit of an issue there. We'll have to come back to. Okay, so that's cool. We've got a CSV. That's like a good starting point. And then I wrote a little notebook, and I'll walk you through sort of the Ben thought process. So I'm going to import pandas. I'm going to tell myself what version of pandas I'm using. That's going to become handy in future cases where I'm looking on Stack Overflow for some question, and they say this feature came out in like Python 9.8, and you're just like, I have 0.23. That's not good. So pointing the version is sort of useful. Okay, I write a little note to myself, where did this CSV come from, right? This gets back to the concept of reproducibility. If at some point, like I don't trust this stuff, is it because I incorrectly copy pasted it? Well, I can go back and like look at the original data source, get the URL. So that's sort of a handy thing to do. So I'm telling myself, where did I get that data? I put it into a CSV, and I'm gonna use pandas to read in that set of data. So I'm storing it in a variable called dframe. I'm pretty lazy and not very creative, so I just call things like df or data frame or simple stuff. All right, then I'm going to use the .head function against that variable, and it's going to return back the first 4 rows, right, with a header. Yeah, there's something wrong there, right? I mean, like, clearly, if you go back and look at this web page, that doesn't seem like a reasonable header at all. Let me zoom out here. Exactly. So it looked at that and said, okay, this is like a comma separated values, and so the 10,000 comma 440 is a new column, and so you're just like, well, that's unfortunate because that's not what I intended at all. And it interpreted the first line as a header. Okay, this is where I'm walking you through the process of how I build up what eventually looks like magic. And it's not magic, it's just me making a series of mistakes, correcting the mistakes, and then building more and more complicated things. Right, so first I tried to load the CSV, and I didn't get what I want. So then I said, okay, I know that first row isn't actually a header, so I'm just going to say comma header equals none. And I know that because I've memorized it, but you'd have to know because you've looked at the documentation. So there is a way of telling pandas, read the CSV, and don't think of the first line as a header. So we're going to go through more and more steps. This is going to get more and more complicated. It's just like little bits of magic that I'm throwing in there to get pandas to do what I want. In the end, it'll be super confusing, and it'll be like, where did that come from? But it's this whole evolution of steps. Okay, so this is slightly better, right? It doesn't have the first line as a header, but it still has that other problem of the comma splits. Right, so if we can look back at what the contents of the file were, we see that that is actually an artifact of the CSV. So I'm not going to solve that problem immediately, but I am going to make the column headers more understandable to me as the human. So that makes my job easier. I can point to things, right? So I'm labeling this as year, city, state, count 1, count 2. This isn't required, it just makes my job easier to think about. And a lot of programming is about making your job easier, right, in terms of like thinking. You want your model to be decomposed and well labeled so that you can think in terms of it very easily. All right, so I've made an improvement there. So again, I showed you one way of like, I can set the column names there. The other way is I can just pass those in when I call the CSV. So now you'll see like the complexity of this initial call just went up by one more thing that we're throwing in there. Okay, questions so far on that? We're just making things a little bit more complicated, but quicker. All right. So now I noticed that like at the top of the CSV that there's two like thousands and hundreds column, and how does Pandas handle that at the bottom where there is only a hundreds element, right? So this is complicated, right? Because now Pandas thinks that the second to last column is the thousandth entry, but when there isn't a thousandth entry, then it interprets the hundredths as that column. Exactly. So then it says, well, there wasn't a last column, so I'll just fill it in with this not a number thing. Right? So it's like a marker saying that there wasn't a last entry in the column. All right, so now we have some idea of the complexity, right? And I just wanted to see a visualization of what this data looks like. Like, how hard is this? I mean, like if you think this is bad, this is the rest of your life as a data scientist. Like, I apologize, but because like, you know, they could have made your life easier, right? They could have just wrapped these values in double quotes, right? And you wouldn't have this problem. But you know what happened? This page, this web page, I guarantee was edited by a human who'd had no concern for future data scientists. That is every one of your customers. They don't even know you exist yet, right? And you're coming through and you're just like, oh, why do you make things so painful? It's just like, they didn't worry about you. All right. So now I have to do a little bit of like trickery, right? The trickery is I have to take the columns that are second to last and last, and I can combine them using this map formula. So I'm documenting what I'm doing, and then I'm doing it. And we see that that mostly works. So we've got, now I've taken those two columns, operated on them. That's goodness. But that doesn't solve the problem where I'm trying to add this number times 1,000 plus not a number. So when I do that in Pandas, it returns back a NaN. You can't add a thing that's not existent with an integer. So now the easy trick that we wanted to play didn't quite work out. All right, so now we get into writing a function. All right, everything's coming together. It's amazing. All right, so basically I pass into this function a given row, and I ask, is that second entry not a number? So if it's not a number, I just return the column that was the hundredths, right? The number that comes second to last. And if this wasn't a null value or a NaN, then I really did have two numbers, and I do want to apply this operation to combine them into a single entry. So it's a pretty complicated sort of trick that we're wrapping this into a function. We have conditional statements. We have multiple returns. It's complicated, right? I wouldn't expect anyone in this class to like show up on day one and know how to do that. So then this is where Pandas sort of comes through in power. I'm applying this function called merge columns. Right, that's the name of the function, and I'm applying it to that data frame, and the output of that becomes a new column. So I'm operating on two columns to produce a new column, and it's a conditional statement. Yeah. Right. So this is, do you want to apply the function every row or every column? So we're going to assume that this function here takes in columns, and so it's going to operate on every single row in a column element operation. So you can switch between those. Okay, so now what did we do? We took those two things and we made a new column called total, which is the thing we actually want. Whoop, whoop. I mean, come on, give it up, right? So let's look at the bottom and see how that was handled. Oh man, this is good stuff, right? So now we've got the numbers, the NaNs that we didn't like, and the number back because this was a NaN. All right, I'll take the applause afterwards. All right, so what could go wrong here? Now, right, we've got the data in the format we want. We've got basically two columns that are relevant. Now we've got the year and we've got the total. Good stuff. Make a plot. All right, I'm going to use a library called matplotlib. It's not easy to use, but we'll be using in this class because it's the most basic one to use. Okay, so I'm looking at my data frame. Okay, looking good. It's got all these numbers, and we'll throw it in a plot. And what could go wrong? All right, so it plotted a thing on the base here. I labeled it as year. That's something that I threw in. Actually, I picked it out of the axis labeled it. Okay, so that is not what I expected at all. That's just like a bummer, right? Because I had the data I wanted. I threw it in MATLAB, and it doesn't work. Sucks. All right. So what's going on? This is the hard part of data science. This is why you get paid the big bucks when you leave here, right? Because I know I need it. I know it's possible. What is so hard about this? All right. This is where you'll spend most of your time, by the way, in this frustrated state, right? So you look through here, you're like, nothing looks wrong here. What could possibly be going on? So you look through here, blah, blah, blah. Okay, so Pandas does this thing that's a little thing, and it basically hides, it like shows you the top of the data frame and the bottom of the data frame. That's like usually where problems arise, right? So by default, if I just do dframe without a head or tail, it just shows the entire data frame, but it doesn't actually show the entire data frame because you might have like a million rows. So it tries to be clever and only shows you a little bit. Okay, so let's go back and look at the data types. Okay, so the year, I would have expected naively that Pandas figured out that year is an integer. That's like a reasonable assumption in my opinion, right? In my experience as a human being. And it said it's an object. Okay, that's probably an indicator that there's something going on there. So it thinks that the year is a string. Okay, this is our evidence that the years aren't the integers we think they are. Okay, so now let's look at the year column and use Pandas to force that column to be numeric. Right? This is a thing that you should expect to work. And it says, I'm broke. I don't know what to do. I got a value error, right? So we go down to the bottom here, it's a value error. And we say, it says unable to parse the string. Okay, so let's go back to our original data. So we're looking through here, 2019, 2000, blah, 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 blah. Scrolling down. Oh, look at that. What happened? World War II, right? So again, this is not like unusual. It's just a human typing a thing in that explains why there weren't any conferences that year because all the people who were bowling were fighting a war. That's a reasonable statement, right? The problem is when we tried to parse it in Pandas is like 1943-45 isn't an integer, so I'll just treat the entire column as a string. Not to mention the fact that like your nan there was obfuscated, but come back to that. Okay, so now we feel a little better. We can set this Pandas set option to max rows 500. This is the thing where we can unhide the entire data frame. Oops. No. Pandas not defined. Let's try this one more time. So anyways, you can unhide the entire data frame. All right. Now I'm going to go off to a different a different notebook where I now know that that's the problem. So I'm going to start with like a clear frame of mind here. We'll read this. All right. So here in this notebook, I'm going to start with all that magic that I had accumulated from my previous session, right? So this is like all of let's skip the headers, none, set the column names. I'm using comma separation, so that's like another trick of, yeah, sorry. I skipped over the part where I'm saying that this column is actually a number by specifying that the delimiter was comma space. So that's a trick. All right. So that's much better. And I'm going to drop row 73. That's the row that has the problem. So now when I run the Pandas to numeric, there's no complaints. That was the only issue in our question. Because if we look back at the other notebook, yeah, so at the very bottom after the error, that's where I run this cell. So now I unhide the entire data frame, and I get the entire back. I could manually inspect it. Where is it? 43. Okay, so that's one way. That's probably not the most elegant way or scalable way, but for this purpose, we'll just get it done. Now we feel better that the year is an integer and the count is an object, so now we try and fix that. But now I've introduced a new error. So remember, I use this trick to set the delimiter to comma space. So that interprets this as a because it has a comma in it. That's unfortunate, right? So now we have to go and fix that problem. Just layers upon layers upon layers of problems to fix. All right, so it didn't like the fact that my string had a comma in it. So I'm going to have to write a function that will undo all of the commas in the numbers. And we'll run that notebook. So basically, I'm just accumulating more and more notebooks that have these fixes on top of each other. So again, now I have consider set to be a comma space. So that's what gets me back to these columns here. And then I have this other magic that says thousands equals comma. So it recognizes that the comma in there can be dropped. And now it's an integer, or a float in this case. All right, that's pretty exciting. We went from a reasonable web page that had a bunch of problems with it. We fixed all the problems, and basically that whole discussion I just made, all those problems I described, they're right here. Right? So if I just showed up one day and said, like, here's a bunch of cool stuff, you should immediately think, this person is hiding hours of work, but they discovered how to do that. Right? That's the whole purpose of why I ran through all of this, is because this looks relatively straightforward and intuitive once you sort of like understand what's going on. But I didn't arrive at it that way. That was the point. I didn't arrive at it magically. Okay, now we can go off and we can actually make a plot. That looks like what we expect. Whoop, whoop. That is great, right? I mean, this is what we're after the whole time. Is it goes up. That's cool, right? For whatever reason, bowling is diving off in popularity. That's interesting, right? Like there was a sort of like fluke here on like 60s. This is what we were after. But there was a lot of work that went into what, 8 cells of probably like 10 lines of code. That was the work. Okay. Questions on bowling or Python? All right. That was a long build up to a good payoff, I think. All right, so we did a little bit of visualization. We're going to dive into a little bit more in this class, and then we're going to go off to the homework. So visualizations are hard to teach. It's more of an art form. There are principles that you can apply to it. So this is one principle that I think is very useful. It comes from one of the leads in the field of visualization, Edward Tufte. So he's got books out. He holds seminars. They're crazy expensive. It's way easier to just read his stuff online. Okay, but this is a recurring principle that you should come back to, and we will revisit. Okay, so has anyone here done visualization work with programming? Just to get a show of hands, a little bit. So not too many people, probably like, I'd say 10 to 20% so far. Okay, so the most common issue that I get from people who have not done a lot of visualization before is just knowing what the opportunities are. So this is a pretty handy website just to gain some familiarity. It's called DataViz Catalog in the links. So it gives you like these little overviews, icons. And so let's click on one of them, the bar chart, right? So it gives you some examples, lays it out, talks about the words, so you get a little description. It's pretty handy, right? And then even some similar charts. So let's go back. No. Core diagram. There's like some crazy stuff. You may or may not have seen these. Like, it's the point is not that you will use every one of these visualizations in this class, right? There is a breakdown about whether it's applicable or not. For the most part, you'll probably be using 5 to 10 different visualization methods, but this is the purpose of me telling you this is just to know that there is a catalog of things that exist that you should be aware of. Okay, so because of there's so much diversity and like cool looking stuff, and you're like, ooh, that's exciting, let's use that, even if it's not applicable. Right? And then, so this is another fun website that there's it's hard to get it right, so most people get it wrong, right? And so this is visualizations that are wrong, basically. So, I mean, this is good entertainment value in one sense, right? But the other value is that if you're straying into this path and you've seen this before, you know, oh, that's the thing that would end up on this website, so I shouldn't do that. All right. So just like it's worth scrolling through here and like figure out like what is going on, right? So it's like I recommend looking through both these websites, but for different purposes maybe. Okay. So right, the leading question here was like, there's so much going on. How do I know what to do? So someone made a chart that answers exactly that question. All right. So this is a chart that I'm not forced to memorize, but it's definitely worth being aware of because it's sort of like a very easy flow diagram of where do you want to get to. This is what is recommended. So one thing you might notice here is that all those charts in the Data Viz catalog are not exhibited here. Right? That's because there are way more like attractive things that look enticing, but are typically not appropriate. Because it may look cool to you because you're looking at data and you want to see something new, but your audience, the people who are consuming your output, are typically not data scientists, right? And they're not going to be familiar with some of these crazy charts, right? They don't want to take half an hour to go read Data Viz catalog to figure out what you're doing. So simplicity has some value, right? There's a reason that only a few of these charts are used heavily. The audience that you're aiming for has to understand the visualization you're making. All right. Yeah. All right. So who believes that this is true? Visualization is like a dead field. No new innovation. Yeah, a little bit. Okay. It's a valid concern, right? Like, how much novelty could there possibly be in the field of visualization? It's been around for literally thousands of years. Right. So there is, and it's really exciting. That's impressive. Like, visualization has been going on for thousands of years, and we're still doing it cool. All right. So this isn't exactly applicable to this class, but like large-scale visualization of complex data is a thing that people need to do that previously wasn't accessible because they didn't have computers. So this whole thing about having computers, that's the cause of why we can do things that we previously have not. Okay. So that was sort of like a eye candy, right? Something that looks good, but wasn't very meaningful. There is large-scale data issues. So like if you want to, look at the entire world at once, your computer has a real problem rendering that. But there are computer programs that allow you to do that. That's good. All right. So grammar of graphics is this thing that is a very active field of development. It's about, rather than trying to say like, put the axis here, put the axis here, put the label here, put the label here, put the plots here, put the points there, like connect the points. Like all that is very tedious, right? It takes a lot of work. You have to sort of know what you're aiming for. The grammar of graphics is more about like, I want a plot that does this, and then like you tell the computer that and it does it, and you don't have to worry about it. So in some sense it's easier, but you still have yet another language to learn about how to tell the computer how to render your graphics. So it tries to do it more effectively than a human might, but it's in its own little language. It typically does things better than humans would do once you know how to use it. Okay, so in this class, I'm not going to drive that fast because it's a little bit advanced for my consideration. So I'm going to stick to the basics. So Matplotlib is one of the older visualization libraries, but very handy and powerful. There's a lot of things to get wrong and right, and it's complicated to learn, but we'll struggle with it. A newer library called Seaborn is built on top of Matplotlib and makes prettier plots, and can do some more advanced features easily, but it has its own little hiccups. So, and it's integrated with pandas. So, I'm probably going to move through this section quickly so we can get to the homework and spend time on that and not keep you too long. All right. So if you haven't gained a lot of familiarity with strings yet, there's some complications in Python. Basically, a keyword that some of you saw when you were doing your matching was the word immutable. It means it's not going to change. So when you think you're making a change to the string, you're actually just making a new string. So, and then the other confusing thing is that strings are actually like lists of characters. So then you can do list operations on strings to access the position and the character in the string. Just something to think about. And then there's like split operations, which are useful for like making chunks of strings into different elements of an actual list. Which, if you think about it, now you have a list of strings where a string is a list of characters. Does that nested list concept come back? Okay. So this is an example of like, maybe I want the last or first 10 characters of a string. You can access it with this index as though it were a list. All right. We have one person who's impressed. Thank you, April. Okay. Right. So I just showed you like one mess of a HTML table converted into a CSV that had some problems. I wouldn't even say that that was bad. Right? That was like pretty straightforward kind of stuff that you'll get used to and you'll be like, oh yeah, that's obvious. But there's things that are way worse. So people unconstrained by reality will do whatever they want with CSVs. So for instance, I have a web page and the web page has an address in it. Addresses have a street, city, state, zip on 2 lines or 3, right? So I'll just put that in my CSV file as a multi-line entry, right? And if it's HTML, HTML has no problem with multi-line cell entries. Okay, you should be worried because that's not going to fit a CSV very well. Right. Also, why not just put multiple different things of categories in the same column? That's cool. Right? No, it's not. Okay. So this one I really like. 8 basic curtains, parentheses, floral, and curtain rods. I mean, from a human perspective, that totally makes sense that you'd want to bunch that into a single entry. Why would you want to split that over multiple columns, right? But from a data scientist perspective, it makes your life really difficult. But there's some value in that. It's really difficult, which means you need a lot of training, which means people are willing to pay you money to do a thing. So you're going to get a job. Woo! Okay. I guess that's a positive spin. Okay. Right. So all of this, what I would consider data cleaning. It's usually not the attractive part of data science. It's the grind, right? It's the part that doesn't get a lot of awareness. I like teaching 601. That makes me a sick and twisted person because my life is data cleaning. Like all that machine learning stuff, the stuff that has visibility, that's 604. You will get to that class, hopefully, or if you're not already in the class. This class is about getting data, cleaning it, analyzing it, visualizing it, all the part that people just think is like, don't even worry about it, right? Like, let's say you spend 6 months cleaning a data set, which to me is not unreasonable, right? And then spend like 2 weeks running your machine learning algorithm. Which one has more visibility to your manager? The machine learning, obviously, right? That's where the attractive sort of skills are demonstrated. Well, what about the time I just spent cleaning this data? There's no glory in cleaning data. Exactly. How are you so incompetent you can't even read a CSV, right? Yes. Okay, I enjoy it. This is why I like 601s. I like that aspect of data science. It's the unglorious part. What I do. All right. You will never, if you get a CSV that is handed to you and is properly formatted, you should be on guard, right? Because it means either someone else did your work for you, or there's some mistake that's hidden that you're just going to hit you over the head eventually, right? Like CSVs are never clean, neither are JSON files. You have to be worried. Oh, and if you hand and the format is correct, the thing that generated the data is probably wrong, right? So like populating the data with correct format does not mean that the data itself is correct. So, yeah, I'm gonna skip over this part. Wait, pandas and series. Right. So this is a tip for those of you who spent more than 2 hours on the homework. I'd recommend checking in with me after a few hours because the hope is not that the homeworks take so long. Right? So if you're straying off the path of it's more than 30 minutes, do something else or check in with me. If it's more than 2 hours, definitely check in with me, all right? Okay. Homework, and we're almost on time. All right, this is not homework, it's just like a task. Watch a video, it's about getting data. That's a preview for next week. So that's gonna be available. Okay, assignment 1 is to write a function. It's not meant to trip you up, but I don't want you to use the print statement to return a thing. I actually want you to use a return statement. Okay, so if writing a function is pretty straightforward for you and you have a lot of experience, my goal is to ask you about error handling. And if error handling doesn't make sense, don't worry about it. So there's sort of like, the initial assignment and the added complexity of error handling. Questions on that? Okay. Okay, assignment 2 is we're going to take a list and we're going to shuffle the list. So we've talked about list and list operations and indexing. So I look forward to that. Also as a separate Jupyter notebook. And then again, if that sounds pretty trivial to you and you're like bored and you want to get a little bit more excitement, I can throw things at you that you wouldn't expect. And then I want you to handle those problems, right? So like if I hand you a dictionary, you can't shuffle a dictionary. Right? That's an issue. Okay. Questions? We're good. All right, the third assignment, this is out of 3, so no more. We're going to download a CSV, and we're going to apply some operations to it. So we didn't cover all of these operations in class, so I left some of those as links. But the Jupyter notebooks that I did use in class will be posted to Blackboard, so you can take a look at those for tips. What else? Yeah. So this is those 2 links there, the here and here. Those 2 links contain a set of CSVs. This is that constraint I was talking about with the data size, just to evaluate that. And then, so like the advanced version of this is don't download the CSV to your disk and then read it into Jupyter. Just read it straight from Jupyter from the internet. If that doesn't make sense to you, ignore it. Okay, questions? Okay. What was it? Ignore it. Yes. So, and if that wasn't enough, so this is a serious question, right? When you leave this class, you'd be like, Ben, there's no one here to teach me Python because I left 601. I'll be like, yes, I know, that's true. So there are people who have the same problem, and they get together and they pose problems to each other so that they can gain skill, right? So like you're constantly looking for ways to improve yourself. This is some sites where you can go and actually like improve your coding capability with problems you haven't seen before and share knowledge with other practitioners. So I'm happy to teach you Python here. After you leave here, you can keep talking to me, but there are other people to talk to too. Okay, so now I know I'm holding you a little bit longer. I'm using my buffer from last time. But I'm asking for a little bit of a start on your homework. And what I mean by that is I don't want you to just sit down on the keyboard, open a Jupyter notebook, and start typing. What I have found is that leads to sort of confusion, and like for whatever reason, there's this like brain fog that sets in when you're at a computer and you're just like, internet, right? And so like what I've found, for whatever reason, I don't know why this is, you sit down on a piece of paper and you write out what it is that you're going to do. And this should sound sort of familiar from the first week of sort of writing a plan of it. And I give you the sort of like steps to break down how do you attack this problem, right? So one of the first week questions was, how do we solve problems? Which is a really good question. So I always start with, what do I want to start with and what do I want to end up with? Those are my inputs, outputs. Okay. And then there's a little preview of the second part. So we have to take the inputs and outputs and then map those through the steps that we're going to take to make those transformations. Okay. So again, I'm going to take you back to this part where for a given assignment, I'm going to request that you stay here for an additional like 2 or 3 minutes on a piece of paper that you do not turn in to me. Just write these steps down for this problem. Go. Pen, paper. If anyone needs paper, pen, let me know. Anybody need paper, pen? No, okay. Need a pen? Correct. It's just for you. It's for us. Yeah. So this is like the leaky part of class where like if you have questions, you can ask them in front of the entire class and I may answer them. It's amazing. So I know that not all of you have memorized all of the features in Python, like, you know, the len command and all that good stuff. That's fine. Write in English whatever steps you think you need to take. And then eventually, when you have access to the internet outside of this class, then you go and say, how do I do that thing in Python? So that's the mapping. So you write down your steps after decomposing the problem, and then take the things that you want to do and figure out how to do them in Python. Okay, so I'm gonna flip over to part. So this is part 1, inputs and outputs. Step 2 for the same problem. Write down those transformation steps in the order in which you take them to get from the input to the output. Yep. Right. So, good question. I'm using words from math, and that's really not a good something. So you've got the things that you're starting with, and the things that you want to end up with. And the thing that changes the inputs to the outputs is the transformation. So it's the change that you apply to the inputs to get the outputs. So in this case, so what would we say that the inputs for this problem are? The string, okay. And what are the outputs? Okay. So now we know we have a thing coming in and we have a thing going out. All right. So the transformation part is what is the relation between those two things, right? Like, how do we get from one to the other? Okay. So I'm not going to force you to sit through this, but basically, I strongly advocate taking the exact same paper-based approach to the second homework problem, right? So you have a thing that is relatively straightforward, like shift a list of elements. But the problem is, if you sit down on a computer, you're going to be like, I don't know what to do, right? So definitely decompose the problem on paper, then take those steps and put them in a computer. Okay, I think, yeah. So the last thing, I'm going to let you out in a minute. You have a half sheet of paper. One side says learn, and the other side says question. So that's a survey for you to write down what you learned in this class, this 2.5 hours, and a question that you have from the content. And do not include your name. Yep. Don't include your name. And turn them in with your name tag at the end when you get them. I will get one. If you're not sure how big to write, write as big as the word question. Okay, yep. So when you've written that down, turn it in with your name tag on the front desk in separate files, and you're free to go.
They upload these recordings.
The what?
They upload these recordings.
They are in Blackboard under recorded sessions. There's a YouTube video on the first week's email announcements that shows how to access that. Or I can show you now.